Hi everyone, I'm Brian Six, Sales Engineer with SUSE, here today to talk to you about securing server applications using AppArmor. Now AppArmor is included with many distributions, including SUSE Linux Enterprise Server and our sister community product, OpenSUSE Elite and OpenSUSE Tumbleweed, but many other distributions include AppArmor as well. And the goal for AppArmor is to help administrators provide a secure operating environment for their servers and their applications. And the key here is that we're targeting application level security and not just general firewall security. So let's take a look at our agenda today. The first thing we'll do is we'll go through an introduction to AppArmor, and then we'll look at how do I interact with it? How do I configure AppArmor? And then we'll do a demo. We'll dive in, we'll look at it in action, we'll get kind of hands-on. Then we'll come back and we'll talk about how AppArmor interacts with this brand new world of containers that we may find ourselves in, and then we'll go do some final thoughts. So an intro to AppArmor. So bad software does what it shouldn't do, and good software does what it should do, but secure software does what it should do, and it should do nothing else. And that's the important key here. AppArmor secures both the good and the bad software, allowing the administrator to define and control what those applications can and cannot do. And that's the goal for AppArmor. Now, AppArmor is considered a mandatory access control system, and it provides a profile for every application that determines, as we see here, what files that application can access, what paths on the file system or network it might have access to. It can even control what network functions and system functions that the application can interact with. So the goal for AppArmor is to give an administrator the confidence to know that if an application were compromised, that the attack vector would be minimized because AppArmor is there leveraging a profile to control that application's access to the environment. And another nice thing about AppArmor is that it's very dynamic. So once you define a profile for an application and then load that profile into AppArmor, it's very dynamic when you want to make changes to it in the future. So as the application, for example, goes through version changes, or you make a change to something in the profile, they are enacted upon real time with AppArmor. And the other beauty with AppArmor is that AppArmor doesn't care who the user is that the application is executing as, even if that's the root user. So regardless of the user, the profile is protecting the environment of the server from any kind of exploit or compromise that could have been done in the application. And we'll see that in our demo, how the being root user does not give you any other privileges that any other user would have had on the network. AppArmor works at the kernel level. So by interfacing at the kernel level, we get the speed and efficiency that the kernel brings instead of just another layered on application that might get in the way of the application running or create a slowdown in its operation. So if we take a look at the architecture slide for AppArmor, you can see here that we plug in down inside the kernel at what we call the Linux security module. And again, we get the efficiencies of running at that layer versus a profile or an application that is running on top of the kernel running in user space. So we get the speed and efficiency that the kernel brings instead of being a layered on application. Now, how do I interact with AppArmor? How do I configure AppArmor to do what I want it to do? Well, the first thing you need to do is make sure that you install the AppArmor utilities package. Now, for our SUSE Linux Enterprise Server, AppArmor is installed by default, but on some other distributions, it might not be installed. So you want to make sure that not only is AppArmor installed itself, but the utilities package is available. And once the utilities package is installed, you'll see here a listing of the utilities that are available, of which I've taken the liberty to circle some of the more common ones that are used. So here are a few of those common ones. The AA status command, great little utility to help you learn what profiles are being loaded inside of your server, what applications are being monitored, and are they being enforced or just being monitored in what we call complaint mode. We also have the AA genprof command, and we'll use that in our demo coming up. That is what helps us to generate profiles, and it is a wizard-like service. So it helps you generate the profile by understanding what the applications are trying to do, capture that, and then generate a profile against it. Then you have the AA logprof. It's an interesting utility because as applications change over time, as the vendor, for example, makes enhancements to it, you may find that the original profile is hampering that particular application's ability to execute some of the new enhancements. So by leveraging the AA logprof command, I can actually take the original profile, determine what, for example, what new features or requests are being made because of new changes in the application, and then record that into a brand new profile so that I capture both the original and what the new feature enhancements are requiring. Thus, I can keep my profiles maintained as my applications change. And then we have the AA complain and AA enforce applications, and what they do is they tell AppArmor in the case of the AA complain option to not enforce a profile for an application, let it just run normally so that I can capture, maybe troubleshoot why an application may or may not be working properly. I want to make sure that AppArmor is not getting in the way. And then the AA enforce takes a profile out of complain mode and puts it back into enforce mode so that I can make sure that my applications are more secure. Now, I want to give you a look at a sample profile, but before I do, I thought it would be helpful to kind of show you what some common permissions are that are used inside of the profile so that when you see it for the first time, it might help you understand a little better kind of what it is that you're seeing. Now, profiles are, for AppArmor, pretty easy to understand, and you'll see that in a minute. It's pretty intuitive, but it's nice to kind of know what it is you're looking at. And so here are some of the permissions that will be used inside of the AppArmor profile. You'll see R for read or W for write. You'll see K for lock. You'll see L for link and M for memory mapping. And then on the right-hand side, you'll see a UX, PX, maybe even IX for different ways of executing and performing certain operations from within the profile. So here's a profile at a glance, and in this example, you can see, starting on the left, that there are some include statements. If you've done any kind of programming, you kind of know what those are, where you're bringing in perhaps libraries or definitions in a different kind of file or location. And then we go through the listing showing you, in this case, access to certain directories, what privileges are being allowed. And I want to make a note or a call to the first line up here. I'll try to highlight that for you here. You'll notice that this particular include statement has a pound in the front of it. And that's interesting because in a typical Linux world, in a scripting language of sorts, pounds usually indicate a comment. Well, right below me, I see, or right below that line, I see a real comment where there's a pound. But notice there's a space here. The include command is a reserved word, so there is no space between the pound and the word include. And you'll notice that in other profiles, there may be other reserved words where there's a pound, but no space. And that should clue you into the fact that that's a reserved word, and that's not just a particular comment inside the file. But pretty straightforward to look at and read. In fact, you can see, again, the rights that are being provided for this particular application here, given read access to a certain location or file. I can even tell that it's granting me the ability to perform certain operations like set group ID or give me access to certain network functions, internet and TCP/IP. So pretty granular access control that I'm getting and can manage inside of a profile. And I've given you a reference here at the top to a link here where you can go and see a profile, and it's identified and outlined piece by piece, almost line by line, kind of giving you a way to get more familiar with the profiles and how they look and learn more about them. So in your spare time, please go take a look at that particular URL and learn more about what a profile is and what are the different sections and the nomenclatures that are used inside of a profile. A couple more things. AppArmor stores profiles on the server by default in the /etc/apparmor.d directory. And in our demo, we will go in and we'll take a look at that directory. But I just wanted you to know that that's where we store profiles by default. There is also a command here for loading a brand new profile. Now, there are profiles on the internet that you can download. People share profiles all the time. And by using the AppArmor parser command with the -a or -r, and please note that that's a lowercase a or lowercase r, I can load a profile from the command line and have that loaded into operation within AppArmor. There is a unload command as well. It's the same AppArmor parser command, but I use a -R for unloading a profile. And again, I specify the path, as you see here, to the profile, but that's the unload option. And then if I wanted to unload everything that AppArmor is doing, I can use the AA-teardown command to unload all profiles so that nothing is being secured in my environment. So let's go take a look at AppArmor in action. Let's go see how the interaction with the commands, some of the ones that we've just described, will look in a real environment. So let's go take a look at our demo. Here's my desktop. I've got two terminal windows open. I'm logged in as root on each because executing and interfacing with the AppArmor tools requires root privileges, and you can either sudo or you can just su as root and do it that way. But I've got two windows open here, and you'll see why here in just a second. But the first thing we'll do is let's just make sure that we've got AppArmor installed, and by default for all of our SUSE Linux servers, it will be installed. But one of the things you're going to want to make sure is that you have the AppArmor utilities package installed, because this package gives you all the interface tools that you need to execute your AppArmor configuration and that kind of stuff. So let's clear that. Let's switch over here to this left side, and let's look at that AA status command. We saw the example in the slides. AA status will show me my current profile enforcement and definitions. So if I take a look at AA status, you'll see that the AppArmor module is loaded, and I've got 46 profiles loaded in enforce mode. And having a profile loaded in an enforce mode is one thing. It's another thing that the application may be running or not. So many of these are, applications that you interact with or a service that you run. But just because I have it loaded as a profile doesn't mean I have the corresponding application or process loaded. And in fact, if I scroll down here, you'll see that there are only 3 processes that are loaded that are loaded and have a profile defined. And you can see the 3 processes here that are loaded and have a profile defined. So, so just notice that here, and remember the count is 46, so we'll create a new profile here in just a minute. We should see that go to 47. And let's start doing that. I've created a little script that represents an application of sorts, and called AA test. And this little script doesn't do a whole lot. It executes a few functions to exercise some capabilities. The first thing that it does is it gives a few comments here, defines a few variables, and says, okay, let's start the AppArmor test script now. And the first thing we're going to do is try or test a file creation command. So we're using the touch command to see if we can create a file in a directory called data, and the file it's going to create is called test file. So pretty simple. And if it's successful, it's going to echo in green that the file was created successfully. If it was unsuccessful, it should turn red and echo that the file creation was blocked. So the next thing I'm going to want to do is test file deletion capabilities. And so I'm going to echo out that I'm going to try to delete something, and I'm going to turn around and try to remove that file. So if I created it and it was successful, I'm going to try to remove it. And then I'm going to, again, print out or echo to the screen if the creation or deletion was successful. I'm sorry, if the deletion was successful or blocked. And then lastly, we are going to try to use the wget command to copy a file from GitHub. And if that's successful, I will print out to the screen, echo to the screen that the download was successful. And then I'll try to remove that file to clean up after itself. And if it's not successful, I will display in red that the privileges were blocked by AppArmor. So it's a very simple script. And if I quit out of here and just run that script, I need to make sure, so I've just written it, but it's not executable yet. So now our script is ready to execute. So let's see what it does. My AppArmor tests the script echo. So it's trying to create a my test file in a data directory that doesn't exist yet. So let's make sure data is there. So there's my data directory, and let me clear this, and let's try to run this one more time. So there's my AppArmor script. It's running. File was created successfully. Yay. Can I remove that file? File deleted successfully. Good. And then lastly, let's see if we can download and, oh yeah, there we go. So it downloaded and we removed that file successfully. So our data directory should be empty. There's our script. So our application, in this case a script, seems to be functioning properly. So the first thing you have to do in AppArmor is we have to generate a profile. Now, in order to generate our profile, we're going to use the AA genprof command. And when we run that, it's expecting a parameter of either the application, in our case, the script, that we are going to generate a profile against. And this script is now going to be controlled or secured by our profile, so that in the event that something malicious might happen down the road, we'd be able to control and curtail the operations and the mayhem that may be executed against from the malware or hacker or something like that, if that were the case. So when we run the AA genprof module, it starts up a little wizard, and basically it tells us that first of all, before you begin doing anything, make sure that for your application that you've verified that there isn't an existing script already created or profile created, because so much easier to use that than try to go build your own. But in our case, we sort of created this script by hand, so we know there's no existing profile. So we are going to, as it tells us here, we're going to run our application. So it tells us to please start your application to be profiled in another window, hence the reason for my second terminal window, and then execute all of its functionality. Excuse me. And so by doing so, I'm going to have AppArmor monitor a particular log, which is what this wizard's going to do, and track all the activity that my script tries to execute, and then run me through all the things that it's discovered, giving me the opportunity to allow or deny each one of the functions, and then it creates the profile for me. So let's leave this particular terminal window. Let's come over here. Let's rerun our script file. And as we can expect, it should run successfully, as it did just a second ago. So there's our file creation. And there's our deletion. And now our download. Okay, good. Everything's successful as we would expect. Now we go back over here to the other terminal window, and we tell AppArmor, scan that system log and see what you find. Now, there are a lot of prompts that are going to be made here. For the most part, I'm going to press I to inherit. Now, because I know my application is running the way that it should, then I shouldn't have to have too much scrutiny on each of the different options. But this is where you could come in and make changes to things and fine tune and control things a little bit. But we're pretty much just going to accept whatever it's providing. AppArmor has recognized all the privileges and requests that the application's making, and it's just going to come to us to confirm that all that is okay. So we're going to say I to inherit. Notice it was trying to execute up here executing the tput command. That's what I was using to help control the color when I echo things to the screen. And now it's trying to access the sleep function. Should I allow it? I allows it. There's the touch command for creating the file. I'm going to I for that, and I for that, and there's our wget, I for that. And now it's changed a little bit. It's recognizing some other functions here. I'm trying to gain access to the TTY, so I'm trying to echo something to the screen. And notice there are two options, 1 or 2. It has by default selected the first one. And so I'm going to hit allow for that so that I can allow echoing to the screen. And do I want to allow the creation of the test file? So I'm going to hit allow for that. And I'm going to allow each one of these operations it's trying to execute. And again, it's providing selections. It's giving me 3 choices that I can make, and it's providing me with the default. So I'm just accepting with the allow function each one of these. So I keep hitting allow. And now it says, okay, you're done with all of the things that your application needed access to, and gives me the option to hit S for saving my changes. It has processed everything. I hit S to save. Now it's back to scanning for the events or finish. So I hit F for finish. So as you see at the bottom, it says finish generating profile for /root/aattest.sh. Yay, so we've generated our first profile. So where did it go? Where are the profiles stored? We saw on a couple slides ago in the presentation that our profiles are stored in Etsy, AppArmor.d. So if I do a listing here, you'll see at the top, there's our new profile that's been created. So let's take a look at that profile really quick. Notice that in my example, the AA test is here, and it's in the root home directory. And if you look at the other ones, it is actually showing us the full path to the file that is being, monitored, either the application, in our case, the script, but they've replaced slashes with dots. So instead of /root/aaTest.sh, it's root.aaTest.sh. And as you can see, the others, we've just replaced the slashes with dots to get down to the file. So let's take a look at our script. You can see here a couple of interesting things. Pretty easy to read, organized well. We've included a whole bunch of libraries of sorts of functions that are already available. And then here are the different files and applications that were being executed in our script and sort of the rights that have been provided by that. So that's sort of what's controlling our ability to run our script. Now, because all is well, right, with our script, we just ran it. Let's take a look at, so we read our script to create the profile. You see that the profile is in the right directory, but is it loaded and enforced? So how do we do that? We run our AA status command again, and I scroll up to the top and look here. Instead of the 46 profiles, we now see 47, and voila, here is our AA test running at the top. So profile running, ready for when that script executes. So because we haven't changed anything, let's run the script one more time. And as you would expect, it should execute successfully because it's doing only what our script or what our profile has allowed. So all is well. So there you go. So our script's running, but our profile is enforced at the same time. So let's go to the extreme and let's consider that someone has hacked in and tried to do something to our script or application and cause it to do something that wasn't intended. So if we take a look at our file, in the original file, as we see here, it was created a file in the data directory called testfile.txt. Well, let's say again, in the extreme, a hacker or somebody else said, well, let's hack in and let's have that file be created someplace else. So let's remove the data directory definition and just try to have the file created in the local directory. And let's not change anything else. Let's just try to do that one. And so let's save that. And let's see what happens if we try to run that script again. Now, remember, we're logged in as root. We're in root's home directory. So we should have full access to execute and do things. But let's see what happens when we try to run that script while it's being monitored by a profile that is controlling things. So let's see what happens. So it starts out. Let's see if we can create the file. Ooh, it's been blocked. Well, I'm root. Should I not be able to create files even in my own home directory? Well, not when AppArmor is in there controlling things. Now, let's try something else. Let's go back into our script file. And let's restore this section. Let's say that again, to the extreme, the hacker malware weren't trying to control that. They were trying to come in here and
let's say they found a way to hack in. They were trying to delete other files. So let's say there's a file called new test file that it's going to try to remove. So they've put that in there because they've tried to delete something else that's out there. And so the creation of test file is going to be successful because we're going to put that back because the profile is expecting that, but it's not expecting this. So let's escape out. Let's save that. Let's make the file that right now, that new test file doesn't exist yet. Okay, so there's our new test file.txt. So our data directory has that, and so just to confirm, new test file.txt, we're trying to remove that. Now, again, we're logged in as root. Under normal circumstances, we should be able to delete that file. But let's see what happens when AppArmor is enforced in profiling that. Let's execute. Our script one more time. Let's see if the file creation works. All right, good. That works, created successfully. Now let's see if we can remove the file. So new test file could not be removed. So if we do a directory listing of data, we should see the new test file is still there, and the test file that we touched earlier in the previous little section inside of our script file is still there because it was not removed because again we changed that to try to delete something else that it didn't allow us to do. So again, AppArmor is doing its job. So let's go back into our script file and let's restore that to its original of trying to remove a file. Let's go down to our next one where we're trying to download. And instead of trying to download the file and put it in our data directory, let's see if I can affect the download and place that file in a different directory. So I've got a user on my box called Santa, and let's see if we can download and place that file someplace else. Again, hacker or malware trying to go in there and have data placed somewhere else on your server or on the network. So let's see what happens when we execute that. So let's rerun our script. Our file creation should work. Our initial file deletion should remove OK. Yeah. But let's see what happens when it downloads that file from the internet and tries to create it. Ooh, download has been blocked. Permission denied. Again, logged in as root, can't execute that particular operation. AppArmor is doing its job. So let's go back and edit our file. Let's put this back to our data directory. Let's take a look at our data directory there. Let's remove that. Everything is clear. So let's rerun our script. It's back to its original form. in which case everything should execute successfully. Good. So we're back to normal. All is well. AppArmor is doing its job.
Okay, another thing that I wanted you to learn is that the PS command, the process status command that we're all familiar with and use almost every day on our Linux servers, understands about AppArmor. So by leveraging the capital Z in my options, and everybody happens to have their favorite, so whatever options you use, add a capital Z, and you will now get to see AppArmor interacting with the process status command, listing all of your processes and showing you whether they are being controlled or managed by AppArmor. So let's go take a look at that.
Okay, so here's our terminal window again. We only need one this time. And let's look at our standard PS output. Everyone's got their own commands that they like to add at the end, the parameters. And I'm just going to stay simple with the capital A. Lots of good information there. Let's add the F so we get the full format listed there. But what about that Z that we were just looking at? Let's add the Z to the end. And you can add this to whichever set of options that you like. So we add that, and now we get this first column listed, and we see a lot of unconfined processes here. And unconfined could mean that there either is no profile in existence, or there is a profile, but it's not in an enforced mode. And but when we did our AA status earlier, remember we saw 3 processes that had profiles defined in an enforced mode. So if we scroll up, we should see those. Oh yeah, so there's the color D that we saw earlier. And there's our NSCD and our ABAHI. So there's our 3 processes. We can see that they are running in an enforced mode. And since that's the only ones we have current processes running with profiles in an enforced mode, that's all we're going to see. So remember, our AA test is not a process. It was a script or an application that runs for a certain amount of time and then terminates. These are always running in loaded processes, so that's why we're seeing them here. But great little interface with the PS command.
So now we've looked at AppArmor as far as its interaction with our traditional applications and processes and even scripts in our demo example. But what about containers, this new world of containers that we're seeing there today? Well, AppArmor works just the same in a container world as it does in the traditional application world. In fact, because containers and traditional applications still use the Linux kernel, AppArmor is still an option for us to secure those particular applications. Now, in a Kubernetes cluster, AppArmor functionality was added in the 1.4 version of the nodes that are deployed in the cluster. And I've given you a command here to help you determine if your nodes are of that particular version or greater, so you can copy and paste that and use that as necessary. I've also referenced a great little tutorial that uses a similar kind of application profile that we used in our script, our AA test script, similar one used in a container world where we can actually test the applications, the ability of AppArmor to control the application and monitor what it's able to do. And the beauty about AppArmor in a container world is that instead of loading AppArmor as a profile that AppArmor is monitoring from the command line, we add content to the metadata file for a container. And I've listed here an example down here at the bottom of what I would add to a container metadata file to reference a particular profile to be used as that container is loaded as a pod in Kubernetes. Now, the trick here, and let me get rid of my drawings. The trick here is that in order for this to be effective, I need to make sure that my profiles for my containers are distributed evenly to all nodes in the cluster. And that's because not knowing where pod 1 or pod 2 or pod 3 might be executed, I need to make sure that those profiles are available so that when that metadata is read, that it can reference that profile, pull that information in, and then leverage that as that container runs within the cluster. And this gives us the ability to have failover and allow those pods and thus the containers within them to move from one node to the next and still be secure. Now, some final thoughts. I hear this all the time. Brian, I've heard of SE Linux. How does SE Linux compare to AppArmor? Well, they both try to achieve the same kind of application level security. But here's an example of how SE Linux would be leveraged to secure the FTP daemon versus how AppArmor would be used to leverage the same FTP daemon. On the right-hand side, I've listed the entire script or profile for AppArmor to control the FTP daemon, whereas on the left-hand side, I was only to reference or able to reference a portion of the script, thus showing you that the SE Linux language is way more verbose and a little more complicated to understand, requires a little bit more effort to learn the language and makes it then, in my mind, a little harder to manage. Whereas the AppArmor side, much more concise, much more well organized, easy to understand, and thus easier to maintain and manage. So both will do the same job. AppArmor, again, installed by default on our SUSE Linux servers, although SE Linux could be used, and you're welcome to try that. It's not installed by default. AppArmor is, and you can make that choice on your own. There are some common use cases that we have run into over the years from our customers, and I've sort of brought them here so that it might spark something in your mind about how you might be able to use AppArmor in your environment. Everyone's environment's different, and everyone has different use cases for AppArmor. But please take a look at these and see if any of these make sense for you. It's a great tool for, again, controlling the applications and giving you, as an administrator, a little bit better peace of mind that if an application were to be exploited or compromised, that you would be able to control its ability and the effects that it might have on your particular servers. So I just wanted to say, hey, thank you for your time.